the cosmos may never end. But if you were immortal, you'd probably wish it would. Our cosmos' final fate is a long and frigid affair that astronomers call the Big Freeze, or Big Chill. It's a fitting description for the day when all heat and energy is evenly spread over incomprehensibly vast distances. At this point, the universe's final temperature will hover just above absolute zero. Until a few decades ago, it looked like that expansion would eventually end. Astronomers' measurements suggested there was enough matter in the universe to overcome expansion and reverse the process, triggering a so-called Big Crunch. In this scenario, the cosmos would collapse back into an infinitely dense singularity like the one it emerged from. Perhaps this process could even spark another Big Bang, the thinking went. In the years since then, the discovery of dark energy has robbed us of a shot at this eternal rebirth. In 1998, two separate teams of astronomers announced that they'd measured special exploding stars in the distant universe, called a Type Ia supernova, which serves as standard candles for calculating distances. They found that the distant explosions, which should all have the same intrinsic brightness, were dimmer, and therefore farther away, than expected. Some mysterious force was pushing the cosmos apart from within. This dark energy is now thought to make up some 69% of the universe's mass, while dark matter accounts for another roughly 26%. Normal matter, people, planets, stars, and anything else you can see, comprises just about 5% of the cosmos. The most important impact of dark energy is that the universe's expansion will never slow down. It will only accelerate. Heat death of the universe. Decades of observations have only confirmed researchers' findings. All signs now point to a long and lonely death that peters out toward infinity. The scientific term for this fate is heat death. But things will be rather desolate long before that happens. Just a couple trillion years from now, the universe will have expanded so much that no distant galaxies will be visible from our own Milky Way, which will have long since merged with its neighbors. Till that our planet Earth, and all of us would be long gone. We live in solar system, the family of Sun, 8 planets, then some dwarf planets and some other celestial bodies, which makes up Kuiper Belt and Oort cloud. And the head of this family is our Sun. But unfortunately, our Sun would die in roughly about 5 billion years in an explosion called supernova. Our Sun would now become a neutron star. The fate of other stars are just like fate of Sun. They go down with a massive explosion, some may turn to neutron star and others to black holes. And soon then these neutron stars would die soon. And there would be no matter left in space for generation of new stars. Eventually, 100 trillion years from now, all star formation will cease, ending the stelliferous era that's been running since not long after our universe first formed. Much later, in the so-called degenerate era, galaxies will be gone too. Stellar remnants will fall apart. And all remaining matter will be locked up inside black holes. In fact, black holes will be the last surviving sentinels of the universe as we know it. In the black hole era, they'll be the only normal matter left. But eventually, even these titans will disappear too. Stephen Hawking predicted that black holes slowly evaporate by releasing their particles into the universe. First, the smaller, solar mass black holes will vanish. And by a googol years into the future, a 1 followed by 100 zeros, Hawking radiation will have killed off even the supermassive black holes. Though this process would easily take a very long time, these black holes would die soon. No normal matter will remain in this final dark era of the universe, which will last far longer than everything that came before it. And the second law of thermodynamics tells us that in this time frame, all energy will ultimately be evenly distributed. The cosmos will settle at its final resting temperature, just above absolute zero, the coldest temperature possible. If this future seems dark and depressing, take comfort in knowing that every Earthling will have died long before we have to worry about it. Our universe will spend most of its time all alone, dark and cold. In fact, on this timescale of trillions of years, even the existence of our entire species registers as but a brief ray of sunlight before an infinite winter of darkness. The universe we had known is now dead. But what after that? Maybe a new universe would be born with its own laws of physics and its own understanding,